Bathrooms are sort of back out the way you came, in the lobby area, men on the left, women on the right. And the fire escape, follow the green signs, and the assembly area is just there and one over there. And the assembly area is the Sofitel, outside the Sofitel Hotel, over the road. We're really lucky to have Soon Wong with us today. Soon is a tech lead with My Food Bag, and just an all-round ninja when it comes to building things in the cloud. So he's been on a journey, him and his team, building Azure Functions, cloud, Azure native capabilities, and yeah, he's going to come and share a bit of the journey with us. So yeah, really grateful to have him along. Yeah, so over to you, man. Thank you very much.
Cool. Thanks everyone for coming today. It's a pleasure to be here in front of you guys to speak to you. As you said, my name is Soon. I am going to try to figure out how to progress these slides without having to press left and right, but that will do. And today's presentation is basically about My Food Bag's journey in bringing Azure Functions as a service offering into what we do for our day-to-day bread and butter. My Food Bag, for those of you who don't know, we are a meal kit-based company, so we offer a subscription-based model for customers to sign up, choose recipes, then it's up to us as a company to do the technology behind it and to fulfill and deliver the ingredients and recipes for them. So we're basically a B2C, and we're relatively, well, I guess we're predominantly cloud first, so most of our systems are in Azure. We do have one or two stray VMs, but you know, every company has a skeleton in the closet. In today's presentation, I'm going to be your chef. Unfortunately, there is no wine with this, no wine pairing with this menu. There is pizza outside, last minute, but there is still pizza. So sorry, guys, online. We are going to start off with a first course of the stack that we used to have as of approximately 4 years ago or 5 years ago, just slightly prior to my time at My Food Bag. It's been dry aged in GitHub for about 4 years. Then we are going to have a look at our current infrastructure stack as it is, which is basically current market flavors. We'll follow that with the plans that we want to do to bring Azure Functions more embedded into everywhere else in our systems. And along the way, there's a few hand-curated sour flavors from things that were found along the way, some things that didn't quite work, some things that might have worked a little bit better. So hopefully it can be a useful guide for you in the future. After that, we will just touch on a few of the intangibles, so stuff around the cost, security considerations, and performance. Before we begin, we probably should have a quick delve into what serverless means for those of you who may or may not have been across it. This is the definition from Microsoft's online website. But for me, I think serverless is really around focusing more on the compute on demand rather than thinking about services that you don't have to host. Ultimately, there's still a server that runs something, but you're not. When you start thinking about a serverless model, you're thinking a little bit less around the underlying hardware and things to provision, and you just assume these things are going to run in the cloud. In the past, Azure was predominantly a platform as a service offering. It still is. When you think about app services, you essentially get charged on a provisioned time and scale model. With something like serverless, the cost model becomes more of a execution time rather than provisioned time. So if you have a service that only runs for 15 minutes a day, you're only charged for 15 minutes a day or some sort of pro rata, whereas in a traditional app service model, you get charged for 24 hours, regardless of whether you're doing anything or not. Moving on from there, we start to look at Azure Functions. And Azure Functions is effectively a serverless solution to enable code deployment without having to worry about the bounds of app services or some of the other tiers that you might traditionally use in a cloud-based model. I kind of like to think about Azure Functions as a framework where, as a developer, you're not thinking about ASP.NET MVC and the pipeline and how the requests get modeled, but you're thinking about what's the code that I need to run to do the business service and to deliver the value. So there's the code side of it. And then with Azure Functions, there's also the how you execute those, which is the triggers. So it's a marrying of code plus triggers. And those triggers out of the box, the initial one is an HTTP trigger or timer-based trigger. But there are others that you can use to extend the behavior. I believe there's about 13 different types of triggers that are marketed out of the box, including some of the more common service-based ones, such as Service Bus, Kafka, RabbitMQ, Event Grid. At My Food Bag, we predominantly use HTTP triggers. We also use queue triggers, so basically using Azure storage accounts, block triggers, and we make heavy use of cron triggers. So we have processes that might need to run at 12 o'clock or every hour or maybe once a month, and we leverage these triggers to build the functionality that we need. All right, so now the interesting part. It's a little bit of a journey in the past, and like anything old and prehistoric, I will probably have got some of the details wrong. There are a few people in the audience who might remember things differently, so don't judge too much.
I've got a question on the previous slide. So
Yes.
Those services that you mentioned, they are all Azure services, Wong and the Kafka. So before Azure Functions, you cannot handle those events with any other service?
So with Azure Functions as a framework, the question was before, sorry, could you repeat the question?
So say you met some triggers from like Labs Trail as an example.
Yep.
Is it not possible before Azure Serverless to handle those events with App Service? Any others?
Oh, so a lot of these would have been possible to handle with app services or other frameworks or other tools. So you can think of Azure Web Jobs, which used to exist, Azure Scheduled Jobs, which used to exist. You might also know that a lot of those services have come and gone, and they've been effectively deprecated, moved to other technologies and things. Azure Functions, I view as kind of an evolution of that as well. So providing a framework to do the code while there are plugins, either out of the box from Microsoft or third parties, to work on the trigger side of things to execute the code. So you can certainly do a lot of this without Azure Functions. But what we're showing on this slide around the triggers is you can build an Azure function that fits with whatever model you've got, whether you're replacing an app service or a web job or a VM or something along those lines. Cool. So back to Dinosaur Land. And I will have a disclaimer. This is probably not 100% right, and this is definitely before my time. But as a cloud-first organization, we were predominantly using app services and app service plans. So a lot of our services and APIs were hosted essentially directly in the Azure App Service Web App Framework. We did have a few on-premise services, and I believe we had a few scheduled jobs, whether they were on-premise or whether they were in the cloud. I can't 100% remember. But from My Food Bag technology perspective, as a B2C, we had a website where public members would come in. So again, app service, perfectly fine for that. We had a logged in account area. Again, public facing. We have a couple of APIs to service both. Again, web. And we had some other internal services. So largely we leveraged the Azure offerings for web-based clients. This was probably about 4 years ago when I joined My Food Bag. At the time, Again, still predominantly web, but we had started to leverage Azure Functions in a very simple way. And I think when you deal with new technologies, it's always easy to think about a small isolated service and start really simple. So for us, we had two areas that I'm aware of. One of them was a small little function that took an image URL and it would effectively compress it or change the sizes. So if you have one of our recipes, which looks really nice, if you download a 10 megapixel, 3 megabyte file, but it's not so great for the web. And we have a function that basically transforms that into various sizes and it handle that in the background for us. So nice and discrete, nothing too complicated. And it's sitting there in the image resize function on the bottom. We also realized there were a few rats and mice activities that we needed to do, such as maybe every hour we needed to check the status of something. And so we started playing around with Chrome-based triggers. You can see though, it's sitting on the side. They're quite complementary services. And so it's a good chance to explore what they do and how they function. One of the interesting facets I found when I joined My Food Bag is, even though diagrammatically they are two different functions, we started off with this approach where we said, let's have a project called My Food Bag.Functions. And so we added the first function, and then we added the second function, and then suddenly My Food Bag.Functions, being serverless with supposedly unlimited scale, we ended up having lots and lots of functions inside there. For the most part, it works, but you do have to watch out, because if you get it wrong, having too many functions in one space, they can start to compete with one another. So we were finding that we needed to do certain things in different scales. So something like the image resizing, that was perfectly happy to be completely serverless. But we were doing some gruntier and gruntier stuff. So starting to think about how we split the functions up became quite important for us. We also didn't really think about what had been inside Azure. And so when you provision a resource in Azure, it's probably worthwhile giving it a meaningful name. This image resize function is still inside our subscription. It still does more things other than image resizing, but we've got plans to move that along the way. One of the other takeaways you can see from, so I should probably call out, these functions were written in version 1. There's now up to versions 4 for Azure Functions. In version 1, a lot of the coding patterns that you have tend to be static invocation. So the classes are static, the methods are static. It's basically like having a public static void main for every function that you've got. As a general developer, you should hopefully realize that statics are generally evil, but within context, we had to play with the dice. It's also at this time that we started to realize Azure Functions could be really useful if we start to break up our work into smaller and smaller pieces of work. So as an example, our customer sign-up flow, we used to wrap a giant transaction scope, and we would create our customer record, create our subscription record, reserve, stock, do all sorts of other random stuff, and then we would send an email. You can imagine doing a lot of work in a giant transaction scope like that. It's quite easy to hit a timeout, and then you basically stuff up the customer's orders. So we realized at this point we could start to use some of the other triggers, such as the queue-based triggers, to offload some of the secondary processing. So for instance, you can write a message to say go and send an email, or you can write a message to say go and update these other systems, and you leave your core processes intact. And it becomes a little bit of a daisy chain, but it does spreads the love. Speaking about queue-based triggers, queue-based triggers are really great in that out of the box you get retry behavior. So if you have a message that fails, the system will provide a retry mechanism for out of the box for 5 times by default, which you can configure in the function. What Microsoft guarantees is that it will run at least once, but you do have to watch out for idempotency. So if I'm going to write a message to charge a customer's credit card $100, and if it fails 5 times, but the failure happens after we call off to the credit card, you might end up charging them $500. It's certainly something to watch out for. In my view, it's kind of a poor man's message bus, but it works a treat out of the box, provided you design your code in the right way to handle those retry events. What's also nice with the default mechanism is if there is a failure, those messages will end up in a poison queue somewhere. Just like Service Bus will have a dead letter message behavior. Azure Functions, if you're using queue triggers, it will go and create a queue for you specifically where those messages will lie. The only downside that we found in Azure Functions v1 through to v4 is that there is no notification when that happens. So the recommendation for us that we've found is we need to build our own alerting watchdog to keep an eye out for poison queues. More things to note about Azure Functions v1. And I have to stress this is effectively going back 3 or 4 years. It was based on .NET Framework only. Wasn't an issue. Our code base was entirely .NET Framework. When we joined, I think we were on 4.5 or 4.6. Went through all the rigmarole of upgrading to 4.7 and then 4.8, and then downgrading to 4.7 because Azure didn't support 4.8 yet. Now it does, it's great. But at the time, you had to also remember they had competing frameworks for .NET Core and .NET Standard. And this concept of .NET 5 and .NET 6 didn't yet exist as far as the public was aware. So architecturally, if we wanted to move onto the new frameworks, we didn't really have the support. Now, that did come a little bit later with versions, well, it came later with versions 2 and 3. And the other things to note, as I said before, there's a lot of static code invocation. And as developers who love CI/CD pipelines and automated tests and everything else, we love to do a lot of version control and dependency injection. And so none of that existed in the version 1 in a meaningful form, and we hand-rolled our own for the most part. The other niggly little point about Azure Functions v1, which is why I would not recommend using it, is there was a hard-coded dependency on JSON.NET version 9, which doesn't sound like a big deal if you're just serializing and deserializing messages. But what we found as we grew the systems, we needed to do more integrations and bring in other NuGet packages, which had their own dependencies of versions 10 or 11 or 12. I won't tell you how we fixed this, other than to say it's pretty ugly. It probably caused scars for a few in the room. But fortunately, version 2 was more or less around the corner. So with knowing that version 2 was around the corner, the downside with version 2 was that it was only supported on .NET Core and .NET Standard. So it kind of forced our hand. We kind of knew we needed to do a technology upgrade anyway. But this became a bit more of a driving impetus for us to start that journey to switching our code base. So we started the journey. Effectively, it's not really related to Azure Functions, but we went down this path of saying, we know we've got a legacy code base in .NET Framework. We're going to do everything in .NET Standard, .NET Core. And rather than re-implementing everything into app services, we decided, let's go Azure Functions all in. Cool. And then this is largely what we have today. We still have a few of our legacy applications and app services. One day we will get around to rewriting them, but obviously trying to sell that to business is always a fun time. We have approximately 25 different function apps, Azure function apps, within another 15 set up for geo-replication. So there's about 40 instances all up, and maybe 4 app services. So we're largely outgrowing the app service model. One of the other key takeaways here is we start to use some of the Azure Global Hosting infrastructure. So we talk about API management services. We did touch with Application Gateway for a little bit, and then we moved to Front Door when that came around. A lot of those services are really useful to use as a wraparound over your core functionality because they can provide scalability as well as security controls over and above the out-of-the-box things you get from Azure Functions. With Azure Functions v2, we could start to do things in a more traditional sense, where rather than having everything start up as a public static void main, we no longer had to deal with static classes, and we could actually start to implement some pipeline behaviors of our own. So one of the key things with SDK is you can define a function startup to point to an assembly, and you can effectively set up your IOC containers, put in authorization, do a bunch of the logic. Maybe not the whole pipeline for what an app service used to do, but enough for what you need your function to do. What that looks like when we consume it is we can define our function as a class. So we can then write our unit tests with proper injection and controls around interfaces. We aren't constrained to .NET. We aren't constrained to the static invocation things. And we're certainly not constrained to JSON.NET. So that's basically where we're at for My Food Bag. We're going full on for .NET Core and .NET Standard. We haven't. I think we're just starting our versions 4 and .NET 6 path, but for the most part, we're predominantly using the Azure Functions v3 framework, and we found that to be a great fit for us as we stand right now. What we do want to do though in the future, and this is the future look, is we basically gut the app services and go all in on functions. The other change for this diagram is we're starting to look at static web apps, which is effectively a serverless hosting option, similar to Azure Blob Storage being used as a website. The principles are the same, where you can use it as a framework to host our web content, while the APIs underneath can get surfaced through Azure Functions. So I imagine probably in the span of a few years, there won't be any app services left within our stack, but legacy apps will still persist, and we'll see. Don't hold me to that. And one last note before we move away from the future is Azure Functions v4. Azure Functions version 4 introduces 2 processing models. One is called the in-process model, the other one is called the isolated process. With Azure Functions v1 to v3, when your function code ran, it ran in an in-process model, which is, to my understanding, it was sharing the same .NET framework within the application. With version 4, you can specify whether you want to run an isolated model, so everything is effectively sandboxed. And I believe the directional guidance is Microsoft will move more towards isolated functions. One key benefit is you can start to host .NET Framework 4.8 on an Azure Functions v4. So if you are bound to legacy code, I would suggest that would be the thing to check. Or you should tell your managers to just upgrade everything to .NET 6. So we'll touch a little bit now about the intangibles, and we will start with cost. So obviously the main selling point initially for Azure Functions is you can run these things and they will be cheap and you will pay next to nothing. But that's only true if you pick the consumption plan hosting model. So with the consumption plan, it's marketed by Microsoft as a free tier. It's not really free, but you pay effectively peanuts on the millions of executions and the compute time. The other hosting models you get are to use app service plans. So even though we're moving away from app services, you can host functions on app service plans and you basically pay the same amount. So if you're used to web hosting in that sense, it won't be any different. And as of last year or the last 2 years, there is an Elastic Premium offering, which is kind of like a hybrid between the consumption plan and the app service plan, where Microsoft manages the scale. If you pick an Elastic Premium, you will have a minimum guaranteed number of instances. It will keep one instance pre-warmed. So if your sales starts to go up, it'll turn that pre-warmed one on, bring it part of the pool, and it'll keep doing that until you get the scale that you need. And they do this to eliminate cold starts. You also pay for it in the credit card. So as a brief example of our consumption plan, this was an export from the past month for one of our core business processes. Use a consumption plan if you don't need the performance to be now, and you're willing to wait within certain time bounds and everything else. We got charged effectively $6 a month for doing lots and lots of stuff that our customers definitely need. Conversely, we also got charged quite a lot of money in the same month for another function. These functions here are more of our customer-facing functions. So we needed effectively an always-on presence because we don't know when our customers will sign in. We have seen customer logins at 3 o'clock in the morning. Don't know why, but they do. Must be really hungry. But we also need the systems to respond to scale. As a B2C, if Nadia goes on TV and does a promotion, or we have some other campaign that goes out, we see spikes in traffic. We can normally, if we manage to liaise with our marketing teams on time, we can set the scales up ourselves. It doesn't stop you from setting up auto-scale rules as well. But having that flexibility to scale on demand is something that's key for us to make sure we don't go down when we try to do a marketing push. So your costs will vary. Now we have a brief chat around security. So Azure Functions natively are hosted in Azure, and they will appear generally as a website that you can access. And those websites will start off generally with public access, which is great if you're doing demo or tech demo things. But when if you're going to build a it will be good to be aware of the authorization levels that come out of the box. So these authorization levels apply to HTTP triggers. And they basically say, if I'm defining a web request, if I'm anonymous, I will let the request go through regardless. If I'm scoped to a function or admin, then I need a special function key or an admin key to get in. At My Food Bag, we basically have most of our functions defined with a function scope. And rather than having the client have to provide that header for us, which is the x-functions-key value, we use services like API Manager. We can write a policy to inject that for us, and API Manager can handle its own different set of security concerns. Similarly, when we talk about security, there's IP restrictions. And these work in exactly the same way as you would expect for an Azure web app. You can either go with service tags, or you can add the keys yourself. There's no difference between what I see in the Azure portal for this or web app. Keynote, though, is you have limited support if you're going for the super free, cheap mode. Especially if your network requires your services to be on a VNet. My Food Bag predominantly doesn't yet. Not too sure if we ever will, but it's a worthwhile call out if that's what you need for your network connectivity. And very recently, in the last year, you get out-of-the-box Key Vault integration. So Key Vault's great. It holds your secrets. It holds it so well that you'll probably never find it if you forget your keys. But at My Food Bag, we take a no-code approach to using Key Vault. So rather than having services in our code that call off to the Azure Key Vault service and do a bunch of things, we actually leverage the inbuilt connections. And the way we do that is you can define a managed identity in Azure, or when you deploy your function, it gets an identity provisioned for you. And you just register that identity with the Key Vault that you need, and you give it the permissions. And then with a super short connection string, if you choose to remember it, you basically drop this into your app settings. When the application starts, it will recognize this as a Key Vault connection string. It will try to call off the Key Vault and fetch the value. And I believe those values get cached for about 24 hours as well. So you're not paying for the ingress for every time the application fires. It's only really when the application starts. And this is a great way to store connection strings and secrets. The last part, we'll just have a brief touch around performance. Performance is largely what you pay for. In saying that with the free model, you pay peanuts, you kind of get peanuts. I believe at an instance level, it's around about 1.5 gigabytes of RAM and a single core. So if you can do really simple things, by all means, go nuts, use that as an offering. But if you've got any sort of computational needs, you have to start thinking about, do I need more cores? Do I need more RAM? And the scaling options are essentially use a dedicated app service plan so you know what you're getting and it's described in the box, or use an Elastic Premium. Elastic Premium is based around the Premium V1 or V2 or 3 offerings from our service plan. So it sort of gives you a bit of a description for how grunty the box is. One thing, though, that you can do inside Azure Functions is this concept of a durable function. Sometimes you just have a business process that you know will take 2 hours or 3 hours, and you kind of sit back and wait and twiddle your thumbs. With durable functions, Microsoft has provided a framework for you to define a series of jobs that it will split up into different activities so that your functions can effectively run smaller pieces of work, and it will orchestrate all of that work together. Out of the box, the default timeout for a consumption plan is about 10 minutes. So if your work can't get done in 10 minutes, you need to look at a durable function. Now, with the dedicated app service plan and the Elastic Premium, I think the default is 1 hour. But because you're paying for a dedicated app service plan that's always on, you could make it 24 hours if you really want. If you have a process that runs for 24 hours, though, you probably need to tweak it a bit. But then there's a word of caution. With infinite scale comes infinite responsibility. So as I was carefully rewriting a service to move into our Azure Functions v3, we put that onto a durable function. That's great. With a durable function, one of the key benefits is you can take a repeated task and fan out. So effectively take 10,000 jobs, split them into 10,000 smaller things, and have it run. I did that and I killed my database. And not a lot of time either. So you do have to be careful. If you have a third-party service or a database or some other dependency that you know downstream can only support X number of connections or this much processing time, you can actually swamp it. But fortunately, in the portal, you can, and probably through PowerShell and through some other means, you can control how much you want these functions to scale. I believe in the past it used to be an application setting. That's changed a little bit now, so I think it's a little bit more streamlined. It used to be beta for a long time as well. But knowing that you can scale doesn't necessarily mean that you have to engage all 200 instances at once. It just becomes a fine line between juggling performance and expectations. Right, and I guess with that, we come to the end of our journey with Azure Functions. I'd just like to say thank you to Microsoft for hosting and providing the platform, and to a bunch of smart peeps that were previously with My Food Bag, who helped to lay the framework, and hopefully we'll cook up some new stuff in the future. Questions?
I've got.
Sorry, just 1 second. We'll use the mic so that we don't have to repeat for the online class.
Thanks for the wonderful talk. Actually, you've covered a lot in a very short amount. Like you need months to just go through so much material that you covered in a short talk. And fantastic experience sharing. Thanks for that. I've got a question around 3 dimensions of serverless, and might be comments and experience sharing.
Mm-hmm.
So it's basically security,
Yep.
orchestration, and developer experience.
Okay.
Right. So on the security front, I think you are obviously in the consumer space.
Yep.
I feel when it comes to enterprise security and enterprise IAM,
Mm-hmm.
Azure Functions still doesn't have, say, the kind of integrations we need for enterprise identity and access management. So I've found, say, we still have to use some of the premium features of AppIM to bring features like AAD B2C. That is not out of the box in Azure Functions.
Yep.
The second point is around orchestration and developer experience. So back in 2016, 2017, when Steven Lasker and Mark Rusinovich were talking about the Azure Service Fabric and ACI with Docker, they were giving this nice presentations in the Ignite or Build, whatever, showing you can publish straight from your code editor, which is Visual Studio, to shift F5 experience into Azure App Service and ACI straight away. So developers didn't need to know anything about infrastructure and servers. So maybe around 6 years later, I don't know how much progress we have made on that front, because we are still kind of back to having app service plan knowledge and understanding, and you still have host.json. You still I mean, I still don't understand why you need to understand the difference between F1, B1, and P3, V3. That's the app service plan, and you have hard-coded machines that you actually get. So it's not totally serverless in that brand, but the experience I would want in that is when my traffic goes up and I know that I need 8 cores or 32 cores, I don't have to, especially if I'm using Bicep to deploy, I have to change my Bicep code to change the app service plan. So from the ACI and service fabric days and this microservice programming model that came with it, there is not a lot of difference today in that space. And I think the third point around orchestration is when, as you said, like the experience you get with orchestration between two different event-based microservices, that actually complicates the architecture quite a lot. So you have to put durable functions, or I mean, whenever you go for stateful applications, then ASB, or you have to play with all those things, which is not out of the box in the Azure Function programming model. So it is still, I feel, not truly serverless in that sense. And other point I had was actually, have you checked the pricing comparison with something like Cloudflare for especially the image resizing and stuff? They might have a much better Jamstack programming model coupled with a very nice reverse DNS and scalable image resizer service out of the box. So that could help you in checking the pricing comparisons.
Right. So there's a few things to cover. So from the first one, from a security perspective, you're right. Not everything is out of the box with Azure Functions. Like anything, if you choose to do security at enterprise level, it does depend on what your security provider is and what sort of hooks they have. There's nothing out of the box for things like ADB2C that I'm aware of. There is some framework code that you can plug in for OAuth support. But I guess it does come down to where you perceive your threat model to be. Do you need a full wraparound service like API Manager? Are you comfortable with code integration for that? Azure Functions is not necessarily going to be a one-stop shop for everything, but I view it as a great way to do the business side of the code if you have another service that looks after security. So for us, at least in My Food Bag, having API Manager sitting on top, that one takes care of the security. We basically offload all of that, and we trust that anything coming from API Manager, and only API Manager, is valid from the function level. So obviously, you're not going to write code in API Manager to do things. But I mean, it's a case-by-case basis, so it's not entirely that. On the second point, with serverless infrastructure, the goal is, the dreams are lofty, but the dreams are never reality. Depending on what you write, you'll be perfectly fine with the consumption plan. But because I guess I had to speak from what I assume was Microsoft's intentions, they still need to make profit somewhere. And they will give you the cheapest thing to get you on board. It would be the same with Amazon, Cloudflare, anything else. And so while you, in theory, don't have to worry about the hardware underneath, if you're going to write a loop that goes over 4 terabytes of data, you probably can't do that on a free tier. If you're just going to do an API call to your database to fetch a single record, you could do. But it also comes back down to your intangibles around, do I need this to be always on? Can I wait for 10 or 20 seconds for this thing to warm up? There's a bunch of those things which, from our perspective, they drive our conversation around, do we host this for free, or do we suck it up and pay for it? And I think from a user experience perspective, being a B2C company, we would rather pay for the hosting to guarantee that there's a bit more of a consistent experience. But there's nothing stopping us from switching everything to free and bringing our Azure subscription costs down. I'm sure Microsoft will love that. And the third one was Cloudflare. Oh, so funnily enough, we do actually use Cloudflare as well for some of our services. Image resizing is actually a really easy example where there's almost no work done, and the cost for us to host that is quite minimal. But you're right, just because Azure Functions is one offering, it doesn't necessarily mean you can't You can't build your systems to use this Lambda function expression or Cloudflare functions or some other things. There's always alternatives.
The distributed programming model
Orchestration
is not gone. That is
no.
nirvana. You still have to understand distributed.
You absolutely do. So if you're going to build a long-running process and these things to fire off in certain events, you might actually be better off orchestrating that in something like Service Bus. But you might have the functions listen to the Service Bus messages rather than being the orchestration. So it does come back down to finding the right tool for the right job. This is what you want to achieve. Functions is a way to do things, but it's not necessarily the nirvana.
Cool. We'll take a question from online, although Marcel's done a great job of answering most of them. So, and if
Thanks, Marcel.
if anyone wants to come off mute and ask a question, you're more than welcome to. So, Chris, for example, if you want to just ask yours, you're.
Yes, can you hear me?
Yes, we can. Yeah.
I just had a question around your development workflow. What does that look like? Do you use Azure Functions core tools for your developers to test locally before deploying up to a shared development environment?
So from a DevOps perspective, we used to use the out-of-the-box Azure Functions tooling that came with Visual Studio, but we've found as we're growing more and more things, we do need to use the Azure Functions CLI for local dev. We've got a strong history in automation. So with our CI/CD pipelines, we actually now provision Azure Functions as we need to on a pull request by pull request basis. So we can test things in isolation before we go into a sort of master template. So there's a lot of template support for deploying Azure Functions. We haven't really touched Bicep, but I'm pretty sure it's there. I'm sure some of the guys at Microsoft can point you out for that. But it's from a local dev perspective, it's quite easy to get the function up and running. And we kind of keep everything sort of in steps in terms of saying, here's our local settings, here's our non-local settings. Shouldn't be that much different if we do proper automation.
I'll ask one quick one then.
Sure.
I presume some of your function calls go across multiple functions. How do you get a good view of how your request spans?
That's a good question. So we do have a few cross-cutting concerns, such as a feature flagging service that we run in the background. So our core service will eventually call that service, and it'll call the other service. We use application insights predominantly as our logging framework throughout all of it. And so a lot of that is on the same instrumentation key. There's stuff out of the box where that sort of stuff gets picked up by the application insights chain, but there's nothing stopping you from implementing other patterns such as passing your correlation ID through and getting that across. It will happen. It's as much as we want to avoid a microservices architecture, you will eventually have services that call to some services just depending on how big or small they are.
Cool. I think that's us in terms of time. So thank you everyone for coming along. And thank you everyone who joined us online. We got about 84 people online as well. So
thank you, online peeps.
awesome. Thank you everyone. One last round of applause.